Okay, so hey guys, it's another Leetcode problem today, and I'm entering the graph topic. So the question goes something like this. Let's get straight into it. It's called the youngest common ancestor. Uh, the problem statement is you're given three inputs, all of which are instances of an ancestral tree class. I can see that the class has a name attribute and an ancestor attribute. Uh, pro- like going by the meaning, I would say that ancestor would refer to the parent node in that particular tree. Uh, like okay, class that have an ancestor property pointing to their youngest ancestor. Okay, the first input is the top ancestor in an ancestral tree. Okay, so they're giving me the root node of the tree. uh, that is the only instance that has no ancestor. Exactly, that's the root node. And its ancestor points to null. The root doesn't have a parent, and the other two inputs are descendants in the ancestral tree. Well, I'm supposed to write a function that returns the youngest common ancestor to the two descendants. Okay, so note that a descendant is considered its own ancestor. So in simple ancestral tree below, the youngest common ancestor is A and B. Okay. Okay, so it's kind of like, if you can imagine, the first intuition that might come to your mind is something like a HCF or an LCM kind of a logic, that you want to find the most common ancestor, like your highest common factor or lowest common multiple, whatever. That's the kind of thing that came into my mind as well. Uh, so we have the top ancestor. Oh, just a second. I think we lost this. Okay, so we have the top ancestor, we have the two descendants, and we're supposed to find which is the lowest common ancestor, or the youngest common ancestor, uh, for the uh, for both the nodes. Okay, so what can we do about this? We have the two nodes, but we don't know where those two nodes are. They might be like the one node might be in level one level below. This another node might be two levels below. They might be on completely different planes, completely different levels of the tree. So when we have no idea about the depth in which they're placed in, it gets difficult for us to find how the common find the common ancestor, basically, because the common ancestor is obviously above the node which is higher when compared to both the descendants. So the first thing that we have to do, the solution goes something like this. The first thing that we have to do is find the depths of each node, so that we know exactly where they're placed, at least the level at which they're placed in. So when we know the depths of both descendant nodes, what can we do to find the common ancestor? uh, can we traverse both of them simultaneously until something gets common? Yeah, well, that is something that we have to do, but before that, we should bring the lower node. If one is on level 1 and another is on level 3, if I bring it up to two levels, and if I match the two levels, then if I have the option to iterate both of these nodes simultaneously, so that if at all something gets equal, so that will be my youngest common ancestor that I'm looking for. So that is the approach that we're going to take in this problem. So let's just get right into coding. uh, okay, so I have top ancestor, I have descendant one. The first thing that I have to do is find the height of both these descendant nodes. uh, okay, let me just define a method called as get depth. I'm gonna take in the top. I'm gonna take in the node, and I'm gonna take in the top ancestor. Yeah, that should be enough. Because I'm gonna modularize this, because I'm gonna have to do the same thing for both descendants. So it doesn't make sense in running this while loop two times. Okay, writing this while loop two times, it has to run two times. Okay, I'm gonna keep height is equal to 0, and while node is not equal to top, I'm gonna keep the node is the one that I'm receiving. I'm gonna keep going up. You know, when it goes to the top, and I'm also going to increment the height variable. When it eventually goes to the top, I just return the height. I think this is simple enough. So we can get both depths using this method. Depth 1 is equal to get depth of let me go for the first descendant and the top ancestor, and then similarly for the second descendant I need to do the same thing. Okay, so now we have depths of both the nodes. We know what level both of them are, but we don't know which is on a higher level. So it can only be two different cases, right? If depth 1 is greater than depth 2, that means one has greater depth. That means one is lower. One is lower than 2. Hence, the descendant 1 is in a lower position compared to descendant 2. So I want to make sure that I call a method which will return me the most common which will return me the most common ancestor basically. So I'm just going to call a function here called as I'm just going to call a function. What can I call? Something like get me the common ancestor, get common ancestor, and I'm going to pass in the lowest one first. I'm just going to maintain an order here. In this case, since one has higher depth, it is definitely lower in position, and 2 is definitely higher in position. And I also need my top ancestor to keep track of how far should I and how long should I run the while loop for. Okay, I'm gonna make sure that I return the actual answer here. So I'm gonna return whatever this gives me, and if it is less than or equal to, if it is less than or equal to the case condition, the else case condition, I'm gonna pass descendant 2 here, because descendant 2 will be in a lower position, and I'm gonna pass the same thing, and I'm gonna return it. So it's my responsibility to write this method now such that it returns me the final answer that I'm looking for. Descendant 1 is the lower because it has higher depth. In this case descendant 2 has a higher depth, hence it's lower in hierarchy, and this, and I'm going to get the top one as well. Okay, so now I have top is not needed, but I need the diff. So I need the diff. I need to know how their depths are how much their depths are differing by. If this is the case, depth 1 is greater. This is the case, depth 2 is greater. So I have to write that accordingly. Yep, and this is the difference. So while difference is greater than 0, I'm just gonna keep moving the lower upwards, lower dot ancestor. So when this loop finishes executing, I'm gonna have both lower and higher on the same level. So I have an option to move both of them at the same time. Both of them will eventually meet at one point, because it has to meet at the root node, so they will be equal at one point. So while lower is not equal to higher, I'm just gonna do lower equals lower dot ancestor, higher equals higher dot ancestor. Okay, at one point they have to become equal. If it's at the root node, then well and good. Otherwise, before also they have to become equal at some point, because they're at the same level. So I can either return, I'll obviously, by the time it comes out of the loop, I'll obviously have my target node as the answer. So I'm going to return either lower or higher, it doesn't matter. So this will return it, this will be the output of this method, and that is something that I'm going to return. And I think the node, I have to return the entire node as the output, not just the name or something, and I have to return the entire node. So hence I'm returning the entire node here. Let's try to run this code and see if it works. Oops, there was no attribute ancestor. Am I passing this correctly? Depth 1 is greater than depth 2. Okay, yeah, so I got the mistake that I was doing. In this while loop it keeps executing unless I decrement the difference to actually find where I should stop incrementing my lower ancestor. Okay, so all the test cases are passing, and voila, see, that's it. The time complexity of this is so you have to iterate it d times, where d is the depth of the lowest node. So this is a solution of O of d, where d is the depth of the lowest node. So that's the complexity analysis for this question, and just we're done. So yeah, bye. Good night. We'll tune in for the next question.